Logarithm 10 times 10 is 1. So it's negative.
Logarithm 10 times 10. Sorry. Don't say it's 1. It's not 10. It's not times, you know. You have a concept problem. If you don't fix that, you will have a big problem later on. Let me clarify this one more time. Logarithm 10 of 10 minus 2. This is not times at all. This is not times. It is very confusing because a bracket indicates time. This is not time. Just the same way as sine 30 degree. Is this times or not? Times or not times?
No.
It looks like times because it's a bracket. Let me repeat this one more time. Logarithm 10, not times 10 power minus 2. It's logarithm 10 of, I'm not sure what to say, but it is not times. Now, what is the basics? Base the same, the logarithm and the index kind of cancel each other. The minus 2 drops down. Don't say it's 1. I never say it's 1. It becomes minus 2 and that will be the answer.
Okay.
This is what you're supposed to think every time in logarithm when things are nice. It is not for me to repeat, it is for you to repeat to yourself, right?
Okay.
Now, I'm sharing my screen, you can just ignore it. Okay, are we going to the next question?
Yes.
Okay. What is the next question?
Not okay. So
Yes.
25 becomes like 5 squared. Right.
You're talking about the guy inside logarithm base tree, is it? You're talking about it.
Yes. Okay.
Okay. Now, think carefully. That is useless. I say it very clearly to you. That is useless. Most of the time, lah. Not all the time, but at this point, I am very certain that's not useful because the base of the logarithm is 3, correct? Is there any benefit to make the guy inside base 5? Even though you, of course, can lah. You can do that. Is there any apparent benefit?
No.
Okay, so I'm going to write down this is 4 minus. Now, even if I change 1 to 5 to 5, 3, which just please confirm 5 power 3 is 1 to 5.
Yes.
Now, is there any apparent benefit?
No.
You understand me? You don't just blindly do in this. When the base matches, you have an advantage. When the base doesn't matches, you keep it in mind only. You not necessarily have to do it. Just keep it in mind. Or maybe it's useful, maybe not. Clear so far, so good?
Yeah.
Now, there are 2 ways to make this beneficial. First, I use the way without the 5 power 2. So I use the original guy lah. I use the original. Then you choose which one fits you better. Now, you already learned the 3 laws. Am I correct? The 3 laws.
Yes.
Okay. Now I'm going to apply one of the law. Okay. Before the 3 laws, I'll mention there are also 2 strategies. This is something that sometimes is not mentioned clear enough in class. I should have mentioned this if we have time. I should have mentioned this before class starts. I mean, before the school class starts. The 3 laws and the 2 strategies. I will now mention one of the strategies. The strategies are actually more impactful than the law. The laws will be used. The strategy most certainly have. Make all base the same. Whose base am I talking about? The base of the log line. Okay? Make all the bases the same. Now, let's check the logarithm here. Is the base the same already?
Yes.
That actually means the question can be easy. You understand me, yeah? This actually means, hey, the question is easy. I don't even have to make the base the same. The base is already the same. Okay, that means this question, I think, can be done. It should be easy. I'm going to apply one of the law. You tell me whether you recognize it or not. 325 power 4. Did you notice I am applying one of the laws? The 4 was
No.
from here. The 4 jump in. If you don't recognize the law, okay, I'll say it the positive way is saying is the law doesn't make sense.
Oh, I recognize.
Recognize. But you should recognize a pattern, not something that makes sense. Because it doesn't really make sense. What? How come the 4 can jump in just like that? What? And frankly speaking, the 4 can also jump out. If you want to, the 4 can jump out. I'll show you later. But please acknowledge the fact that the law doesn't make sense. It's just that it is easily recognized and you should always be ready to use it. They won't tell you which law to use. Okay, so you're saying that you have recognized the law. So far, so good, lah. Okay, I'm going to use another law. See whether you recognize it. This law also does not make sense. It's just that it's kind of easy to recognize. All the laws are easy to recognize, even though they do not make sense. Did you recognize another law that I use?
I think so.
All right. Then use your calculator to simplify the inside.
On 3,125.
Sounds about right. And that will be the 5 to the power of something. Okay, now I'm going to do something that requires in this. You remember that big number, okay? Remember that big number. And then I'm going to ask you to find that is 5 to the power of what? Can you do that, please? You have to try using a calculator lah. You better try some slightly bigger number. That is 5 to the power of what? Okay, tell me what numbers you try. 5 to the power of? Again, Abigail, you should be trying, not thinking. Try first, then think. So what number do you try?
5.
5 to the power of 5, correct? Which is, I believe it's correct. That's the correct answer, isn't it?
Yeah.
Okay, good. Good job, try. 5 to the power of 5, and then manually I'll do it this way. 5 to the power of 2 to the power of 4 over 5 to the power of 3. And then this will become logarithm base 3, 5 to the power of 8 over 5 to the power of 3, which will give you 5 to the power of 5. That's manual. Calculator also works as long as you're willing to try. And then some people will actually do this. The reason is because they're not very sure how simple should things be. The question asked me to simplify. Is this guy the best or is this guy the best? Some people would prefer the one on the right. Truthfully, it doesn't matter. As long as you do not keep it at 30,000 something. If you spot the 5 power 5, most likely you are correct. Am I making any sense?
Yes.
You probably do not have the instinct to convert the 30,000 something to 5 power 5. Am I correct?
Yeah.
That would be an indice problem, not a log problem. Inside log, indice is freely used. So it is an indication that your indice is not strong. And that is true. Your indice is not strong. This is a chance to strengthen both. Let me repeat it one time. You cannot get good log without your indice getting stronger. Let that be a motivation in that sense. Okay? Don't let that demotivate you, but let that motivate.
Okay.
Now, should I show you another approach?
Yes.
This is the first one. So one more time, I want you to just mention the, do you remember the name of the laws? You don't have to, but if you do, that's nice.
No.
All right. If you do not know the name of the law, it doesn't matter. They won't ask you to say. But does it make you unable to recall them? So let me rephrase my question. If you have a good name for the three laws, does it make you able to recall better, or it doesn't matter to you? What do you think?
Doesn't matter.
All right. Then I will just remind you that the law exists first. Here, you recognize the law. Here,
Yeah.
from here to here, recognize the law.
No.
You said that you recognize the law from here to here just now. Let me confirm. If you don't recognize, we have to talk about it.
I'm not sure which one it is.
Okay. Now I'm gonna forcefully name it lah. Simple enough lah. Oh, this is the power law. The power can go in and go out. Fair enough. Power
Yeah.
law. Go in, go out. The first law, the most useful one, is called the base change law. It's just that we don't use it here. In exam, base change law will be the first thing you use usually. Base change law, I think you understand or remember, Ken?
Yeah.
There are two laws already. Power law, go in, go out. Base change law, the first law that they usually teach, number 1, number 2. So this must have something to do with the law number 3 lah. The law number 3 talks about log plus log or log minus log. So one more time, the law works something like this. Give me two random numbers.
6.
6 and then one more.
9.
Plus log base 6, same thing, and then another one like that, for example. Okay. This, please notice, I'm sorry, I'm going to make it very clear. I'm going to add another one. Give me another number.
5.
5. So there are now 3 logarithms here. The third law, the best thing about the third law is all these 3 logarithms can be just one. That is so advantageous in exam questions. All this will become simply one logarithm. 9 times 7 times 6. Hey, I'm sorry, times 1. It doesn't make sense. Let me repeat, the law doesn't make sense. It just works. They also don't bother to explain why it makes sense. In calculator, you will see that it works lah. But they basically just say, hey, it works, do it, or recognize and do it. Now, I'm presenting this third law as an opportunity to you, an opportunity to reduce more than one logarithm into just one logarithm. This is so useful in exam. Do you understand how the law works?
Yes.
As long as you recognize it, please do. Now, the law has two sides, the negative one also. If this is negative, this is divide law. Okay, Ken? That's all. Now,
Okay.
recognize the fact that there are two logarithms here. The base are the same. You have fulfilled the requirement of the third law. There are more than one logarithm. The base of the logarithm is the same. Hey, the requirement fulfilled. There's a minus sign here. You have the opportunity to reduce two logarithms into one, exactly what I did. That is how the third law feels like, an opportunity to reduce the number of logarithms. So far, so good?
Yes.
Do you want to call this law a name? Your own personal name is fine. Please tell me what name.
I don't have a name.
Then what should we refer this to as next time? If you have difficulty referring it to, we'll be wasting a lot of time. We need a name or something.
Can't think of one.
The no name law. Okay, that's what you're saying.
Okay.
We have the base change law, the power law, go in out, and the no name law. As long as you remember what no name law means, I'm totally fine with that. Now, any question on the law so far?
No.
Now, I promise you to show the other way of doing it, right? So the other way is then you can decide which one is less confusing. Now, I'm going to do the power law, but going out. Just now, I do the power law going in, right? So help me. I'm gonna do the power out. So what does that become?
8
Then what?
negative 3.
Log base 3, 5. What are you talking about?
Oh.
All right. And then negative
3.
3. And then
Huh?
log base 3, 5. Where's your log base 3, 5?
Yeah.
Then say it out. Then say it out. Say it out.
Okay, log base 3, 5.
Right. Now, in this case, is it helpful for me to, so to speak, kick the power out? Do you see any way of making this simpler now?
Yes.
And then what will be it? Would you like to write down?
Okay.
You need the bracket for the 8 minus 3, yeah? So that it's not confusing to the teacher. Okay. And right now I will say that, okay, what you're doing is wrong. Okay. Okay. I'll explain later. Continue. I continue, I begin. Why do you leave the 8 minus 3 in the bracket? Please don't do that. Okay, waste of time, waste of time, waste of time. Don't leave the 8 minus 3 as 8 minus 3. Just keep it as yeah, there's no benefit at all in keeping them as 8 minus 3. Yeah, you should keep it as 5. Now, let me explain again why there's no divide by 5. Okay, you don't apply the law here, right? You don't apply the law here. This is simply 8y minus 3y. If that makes sense? If you see it that way.
Yeah.
So if it's 8y minus 3y, then you'll just get 5y. That's easy, right? No problem. And then once you let, you must always return it back to the original. 5 logarithm 3 base 5. You're returning it back to the original. Make sense?
Yes.
Now, are you confused that there is no 5 divided by 5 here?
Yeah. Why?
Okay, now let me explain, and I'll start my explanation and say it does not make sense. You just have to recognize how the law works. Look at how the law works for the no-name law. The no-name law works like this. The base must be the same. Okay, great. The base is the same. There is nothing in front of the logarithm. Did that make sense? There is nothing in front of the logarithm. If you want to apply this law, there must be nothing in front.
Oh, okay.
Which is why I kicked the 4 in just now. It was to prepare me to apply the no-name law. Do you understand? If I don't kick it in, I cannot apply it. So far, so good?
Yeah.
The second method, that means, commits to not using the no-name law because I actually kick it out. If I kick it out, I already know I am not going to use the no-name law. If I want to use the no-name law, I should be kicking things in because that's the requirement of the law. Doesn't make sense, but that is the requirement of the law. So far, so good.
Yeah.
So in this situation, you cannot apply that law. Instead, you just use a simple trick like this to just make everything clear. When you use the lab, it is quite clear the answer should be 5y. And therefore, 5 log 3, 5. There is no 5 divided by 5. I apologize if the law doesn't seem to make a lot of sense, but you need to recognize the requirement.
Okay.
Okay, right. Now let's talk about B before you do it by yourself. Look at B. Now, what do you plan to do? You don't do it. You say to me what you think you want to do. Okay, I'll start our discussion, Abigail. We don't wait too long here. The base of the logarithm is the same or not?
No.
It is the same. What do you mean by that?
No base.
What do you mean by no base? Ln is logarithm base e.
Oh.
Do you know this?
Yeah.
Is the base of the logarithm the same?
Yes.
Remember what I say? It is a good day. Hey, logarithm, the base same. Hey, this is a not so difficult question. You should just apply the law, well, to your advantage. So, base change law, power in out law, or the no name law? Do we base change here? Yes, no, or you don't know?
Base change.
Yeah, do you base change here or not? Is it to your advantage to base change here? Yes, no, or don't know?
Yes.
No, it is not to your advantage because the base is already the same. If the base is different, hey, let's consider base change. The purpose of base change law is usually to make the bases the same, if that makes some sense.
Okay.
Right, so the bases are the same right now. So, okay, let's not consider base change law here. Second law, power in out. Third law, no name law. Should you consider power in or power out?
Power in.
And usually, or rather, the only reason, I can tell you the only reason why people do power in is to prepare for the no name law. It is that simple. It is so that simple. If you're trying to power in, you must be considering some sort of the no name law, the law that allows you to reduce logarithm from many to one. Am I making any sense?
Yes.
Then please do it in the next page. I've already made a new page. Please apply your power law, power in or out, in preparation for the no name. Abigail, you say that you want to kick the power in.
Is this not power in?
Oh, goodness. Look at the previous page. Are you there?
Yes.
This one is the one power in. The 4 goes in. Do you understand that that is power in? 4 goes in. It doesn't make sense, but it works.
Okay.
The power out, the 2 goes out. That's the power out. Power in or power out. Would that be okay? Now, still in the previous page, we did discuss whether making 5 square is beneficial or not. Whether making 5 cube is beneficial or not. Do you remember that discussion?
Yeah.
Is 5 square in this situation beneficial? Yes or no? The reason being? Very good. The reason being?
Doesn't match with the base of the logarithm.
Of the law. All right. Now, in your case, there is nothing wrong with you trying 6 cube. But you must realize that it is not beneficial so that you don't get confused. Not so that you get disappointed. I'm totally fine with you trying it. I'm worried that you do not know it is not beneficial. Then you get stuck because you think it should be beneficial. Do you understand what I'm saying?
Yeah.
That is not the power law, by the way, lah. Just saying. That is so not the power law. What you did just now is an application of the power. Great. Trying it out is totally great. Recognizing whether it's beneficial or not is more important. You do another power law. If you're confused, yeah, just write it down as power 4. Good. There's nothing wrong with this. Tell me, this looks less nice, right? This new direction that you're trying, frankly speaking, looks not as nice as the first one. Correct or not?
Yes.
Then tell me, is it me forcing you, or do you have another benefit that you're chasing here? What is the benefit that you're trying to achieve here? Any idea?
No.
Okay, I explain to you one more time because it does not make sense. That one I admit lah. Logarithm just doesn't make sense. If you do power in, my explanation goes. It is in preparation of the no-name law. What is the benefit of the no-name law? Here's an example of the no-name law. What is the benefit of the no-name law? Many logarithm into one logarithm.
Yes.
Many logarithm into one logarithm. That is the benefit. Now let me ask you one more time. Why do you prefer this one compared to that one? The top one just looks much nicer. Maybe I am wrong. Why do you want to do the second one? Maybe I'm just forcing you. Maybe it is useless to you. Maybe I'm wrong. Why? What is the benefit of you doing the second option? What do you think? What is the benefit?
I don't know. I'm just following what you did.
Yeah, which is not going to help you a lot in the homework and in the exam. Let me repeat one more time. In preparation of the no-name law, the no-name law allows you to reduce the logarithm into just one. Do you like that?
Sure.
Then let me ask you, Abigail, because I'm not going to do it for you. What is the benefit that you're trying to achieve here? Do you know? Don't just follow me. It doesn't work for you.
No.
Then don't do it. Do yours. But just in case, keep this around. Keep this around. Let's keep it around for a while, just like a pause. Do what you think is best. Do it better that way. That works better for you. Abigail, what are you doing? How come that's 7? No, Abigail. How come you can 3 plus? How does that work?
Wait.
What's going on here? Stop following me blindly. Oh, you're kicking it out. Okay, good. Okay. You do the power kick out. That's great. That was great. I like it. Okay, let's see what happened. And see that you're kicking the 2 out. Okay. All right. Abigail, stop that. Why are you ignoring the -1? Stop that. Don't pretend that the -1 is not there.
Okay, I pulled out 2, so like 4 times 2.
No, I don't understand. Where's the -1?
What do you mean?
What do you mean? There's a -1 there.
This.
Yes.
Then I'll just multiply that.
Let me ask you, the -1, can it just be gone or not?
No.
Yes, so put it somewhere. It disappeared in your working.
But I don't know where to put it. Just leave it
Yeah,
like
if you don't know what to put it, you cannot just ignore it. You at least leave it there lah. How can you just make it disappear?
I'll multiply it with 4 times 2.
You mean you want to power law it out, right? That's what you mean, is it?
Yes.
That's totally fine, but just don't leave it gone, right? Go ahead, try. If you want to power it out, no problem. Making it disappear, not good. Looks great to me. It's good that you confirm.
Okay, what do I do with like the 6 over here then?
Let me ask you one more time. What is the requirement of the no-name law? Can you apply the no-name law here? Can or no or don't know? It's okay.
I don't.
It doesn't make sense. You know or you don't? Sorry.
I don't.
You don't know or you sorry, what do you mean by you don't? You don't know, is it? You don't know.
I don't know.
The requirement of the no-name law is that there is nothing in here in front. The base must be the same. You have not fulfilled that requirement. You do not need to consider the no-name law. If you consider the no-name law, it confuses you and you mean you don't recognize the requirement. The requirement is nothing is here. Okay, second time. Would that be okay?
Okay.
Now, what to do with the 6? I told you, use a let. It will make your life much easier. Use a let. Let's use let to make our life easier. Let something be y. What will help you with a let here? Let what be a y?
IN6.
6. ln of 6. Yeah, ln of 6. Yeah. Go ahead, ln of 6. Go ahead, ln of 6. Now, let's see whether that truly does make your life easier. Give it a try. All right. Now, once you seems to help you. Once you have let, you must return back. Okay, so return it back. Just return. No. Stop. Just return back here. Just return back at the final answer. It's totally fine.
What?
Abigail, your final answer is y. You must return the y back. When you let, you must unlet. Your final answer is y. Return the y back to the original guy. And that will be the finalist answer, so to speak. You cannot start at y, even though y is so good already. You must stop at finally logarithm natural 6. So far, so good?
Yeah.
That's the manners of y. That's the manners of let. You must unlet, so to speak. Yeah, you must unlet. Any question?
No.
Right.
But
First method. You're saying, sorry, what? Sorry.
I see it now.
Tell me what you see. What is it?
What the y does.
I guarantee you, in A math, this technique let is useful in at least 4 topics. Logarithm, that's one of them. In this, another one, then another 2 at least. Good for you if you see it. Oh, they will use it a lot. Okay, good for you. Now, I need to show you the second method because the second method will also be useful in other questions. First method, clear first, however. Are you happy with your original method?
Yeah.
Your original method make use of the 6 cubed and the 6 squared. Congratulations, it turns out to be useful. Useful to you. Next time your teacher does it another way, it's okay as long as you know your method has its uses. Let me tell you, your teacher will not prefer this method. I don't know why. Hey, it works for you, so it works. You know why certain things are useful. That's important. I need to show you the second method, okay? Here's the second method. The second method is the weird looking one. I understand that people don't necessarily like it. However, I must ask you to do it. Now, has this fulfilled the requirement of the no-name law?
Well, yes.
Then please apply the no-name law no matter how weird it is. Please do so. So that when you see your teacher do this, you understand, oh, that's what she's doing. How come I'm different from my teacher? Well, there are more than one way, so to speak. You're applying it correctly. Right? You're applying it totally correctly. Press the calculator.
I get 6.
Yeah. And so, final answer, go ahead first. Yeah. So both method, different approach, give you the same answer. It almost certainly mean you are correct. If the method is so different, but they give you the same answer, that means both are correct. But that means your preferred method is correct, which is a good thing. Make sense?
Yeah.
Right? Now, who is to say which method is superior? How do you say that? Which one is better for you? What do you think?
Why?
I agree. What is good for you is what you understand, or rather, you will say that you prefer the Y method, right? Now you see it, you understand. I agree. The one superior for you should be the one you understand. The second method, however, will be useful in other questions, so please keep an open mind. Okay? You don't understand it yet, you don't like it yet, but please keep an open mind. Okay? Promise me that. Right.
Yeah.
Now, really good job understanding logarithm, where the topic is, frankly speaking, a lot of nonsense. The laws are nonsense. The indices are confusing. Good job understanding it. Let's move on. We have 2 more minutes, right? Okay. Maybe 7 more minutes. Maybe 7. Then I have to talk about the future. Now, which question now?
Question 5A.
Right. Now, there are 3 laws: base change, power in out, and the no-name law, right? There is also indice involved always, and I told you there are 2 strategies. Let's revisit the strategies. The first strategy I told you is make the base the same, correct? Make base the same.
Yes.
Let's look at this question one more time. 5A. Are the bases the same?
No.
Correct. The second guy, logarithm base 6. The first guy doesn't even have logarithm. How can the base be the same? Now, the strategy. Strategy is not law. Strategy is not the index. Strategy is really what approach works in exam. So I'm telling you, one of the approach which works in exam is make the base the same. If there is no logarithm, well, make the logarithm appear. As strange as this sounds, I'm going to make logarithm appear.
Okay.
Watch. After that, I'm going to ask you, do you see the benefit or not? Only when you see it, then it matters for you. If not, then what's the point, right? Okay, I'm going to keep the guy behind the same, and I am going to do this as logarithm base 6. 6 power 2. Let's be very clear about this. Do you understand what's going on here?
The base 6 of the logarithm and 6 cancel each other out.
So by right, this is 2 lah, right? By right lah.
Yeah.
by right, you want to go from here to 2, correct or not? That's our preference. Our
Yes.
preference is to go from here to 2, but I'm asking you to go backward on your preference. Can you accept that? That's just
Sure.
so weird. Now, if you accept my suggestion, what's the benefit? Do you see the benefit or not? You must see the benefit. If not, you won't buy it. This is making your life more difficult, not easier. If there is no benefit, for what? Tell me,
Um,
what benefit
can
do you see?
can just have one logarithm 6.
Which law are you talking about? Base change law, power in out law, or the no name law?
No name?
No name law, the one that makes many logarithms into one. You have fulfilled the requirement. Base the same, there's nothing in front. Please apply your no name law. Press the calculator. Right. Has this fulfilled the question's request?
Should be.
Yeah, so I agree with you. Let's move on to question 6, and then we are running out of time
I
already.
know
We
how to
have to
do
talk about the
calculus.
future. Of course. Now, use the calculator. Now, when they say use a calculator, that's already a very big hint. You know that a calculator only have 2 bases, ma? Correct? What bases is that?
Yeah.
Base what and base what?
10 and E.
Do you know that whichever you choose, you will be okay one double? Do you know that?
Yeah. I know how to
Now,
do
they say
question 6.
use. Oh, you know, I'm sorry. Base change law. Okay, great. I'm sorry. Okay. Now, let's move on to the next one. Okay, we have one more. Oof. Okay, is it this question? Is it the, what is this question?
One.
The logarithm base 381?
Yes.
Okay. Okay. Now, what exists in logarithm, as in what helps you? The 3 laws in this itself and the 2 strategies. One of them I already tell you lah, correct? One of them are basic. Okay. Let's remember that.
Yeah.
That's our tool. You seem to be comfortable with that. Oh. You like the other one. You like the lab. Okay. No. I'll put the lab. The lab is a strategy. It's worth noting. It's so worth it. Okay, lab. Okay, good. Now, this is going to be so weird. Evaluate each of the following without the use of calculator. It's very weird given the fact that this is a very high decimal point and you will be using it anyway. Okay. So now let me say what he's trying to do here. Okay? He's trying to make your life complicated. This question is not the best thing, but he's trying his best to teach you something important. Without the use of calculator is nonsense because there are so many decimal points, you end up having to use it anyway for the decimal points. Do you understand what I'm saying?
Yeah.
So that use of calculator is nonsense. The second nonsense is, first nonsense is too many decimal point. The second nonsense is, by right, you already can base change, correct? Now tell me, what's the base change here?
Hmm.
Apply the base change law, please.
Uh,
You say you know how to do question 6, yeah, so I expect you to be able to do this. It's the same thing for base change. Come on, don't wait too long.
logarithm.
Base.
Logarithm 80.
Base what?
Base
Sorry. Let me just base what? Sorry.
base
Base
80.
base 80. Okay. And then
Huh?
inside. Why is it base 80?
No, no, it's
It,
just
what base are we talking about here?
no, nothing. We use the calculator for that.
Oh. When there is nothing, don't fool yourself. It's actually base 10. When there is no base, it's base 10. You got to be clear. There is no such thing as logarithm without a base, but the calculator makes it seem that way. Can
Oh, okay.
understand? Okay.
Yeah.
There is no logarithm without base. Be clear. It's just that the calculator is okay. Great. Yeah. Okay. Logarithm 10 and then 3. Okay, you're right. And then you press the calculator and then you got the answer already. Okay. This question is nonsense because in exam, you will immediately do this one. So the question seems to do something roundabout. I'm going to explain to you because I hate the way they do it roundabout. Okay, I know there's a good meaning to it, but this is still the best thing to do in exam.
Okay.
Clear, yeah? Okay, yeah. So now I'm going to show you what they mean. They give you a hint here. They want you to basically use 2 and 5. That is a hint. Now, I am going to make my life very complicated. I'm going to do the reverse of the no-name law. The no-name law, by right, compresses many logarithms into one. I, for the sake of the question, which I feel is nonsense, will make one logarithm into many. So far, so good. I am applying the no-name law, so to speak, in reverse of the usual benefit. Okay?
Yes.
80, I believe, is 5 times 16, so 5 times 2 to the power of 4. Please check using calculator.
Can you repeat that again?
Is 85 times 2 power 4.
Yes.
Good. Why am I doing this? It's so weird. Because I get the hint. I get what the question is trying to ask me to do, which I still believe is nonsense as a complicating life thing. Right? But I get what it's trying to do. So again, see, because I get it, I now apply the law in reverse. I will now get more than one logarithm, see, plus logarithm 3 to power 4. Do you understand what I'm doing?
Yeah.
Applying the power out, I get the 4 upside. There you go. Can.
Can.
And then because of that, I am using what the question is asking me to do again. Which at this point, do you realize I will still need to pick up my calculator? This is 1.465 plus 4 times 0.6307. I mean, I can do this manually, but why would anybody want to do that? Do you understand what I'm saying?
Yes.
Now, please try this and compare with your initial base change. Please confirm that both answer is the same. Are they the same?
Hold on.
Be faster with your calculator.
Yes.
Okay. Let me repeat this one more time. I know what the question is trying to teach you. I believe they are not doing it in the nicest way possible. Because there is no point doing this in exam 1. You still have to use calculator. But if you write this down in the exam, they will consider this not using calculator. Because technically speaking, you can do this manually. Well, who will do that? But you still technically do not have to use the calculator if you write this down. This one, true enough, this one you have to press the calculator. So there is no way to avoid the calculator.
Yeah.
This is better according to their requirement. This is so much better in exam. Again, let me repeat, in exam, you will just need this.
I know.
If you understand, can I leave the question B for you?
Okay, sure.
Yeah, you'll just be doing something roundabout. Okay, I'll make a last comment on question 10 and we'll talk about something in the future, right?
Yeah.
Now, question 10, you notice that this is times, okay? This is times, this is time, this is also times. Okay, why am I asking you to pay attention to this? Because of the three laws. Base change, power in out, and the no-name law. Now, my question is very direct. Can you use the no-name law here? Does this fulfill the requirement of the no-name law?
No.
Very good. If you understand that logarithm, this times logarithm, cannot use no-name law, you're on the right track already. You must use some other way to do this. So now, the base is different. So let me repeat the strategy I give you first. Okay, you may want to try changing. You may want to try three law, indices, and the two strategy. One of them is left, the one that you like. One of them is make base the same. You may notice that the bases are different, and maybe, just maybe, making the base the same might be helpful. That's my hint to you. So two hints, don't use the no-name law. You cannot force it. Secondly, make base the same. See what it is. Would that be okay for the homework?
Yes.
Okay. Now, I want to talk about something in the future. Let me confirm that your teacher is not far from question 10 in class. Can you at least remember what's happening in class? If you don't, please tell me.
I can.
Okay, then can I confirm your class is around question 10 or way ahead of question 10?
Around question 10.
All right. Then which chapter is this? Like subchapter something point something?
6. Chapter
Point 6 point.
3.
Okay. There is a 6.4, I believe. Ken?
Yes.
Take a question from 6.4 and paste it in page 18 right now. We are going into the future. I want to show you a few things about the question. Any question that appears you cannot do, obviously. Talking about the future means you cannot do it by yourself. That's why we have to issue. Please choose some questions for us. Hey, just copy it. Oh, can't you screenshot or something?
It take too long.
Oh, okay. Make sure you write down correctly. Yeah.
Okay, this E.
All right. Okay. Is that e to the power of ln A? Okay. That's e to the power of ln A. Okay, good. Okay, then. Okay. 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 Uh-huh. Uh-huh.
Without calculator.
This is All right. This is a question from 6.4. Let me confirm that.
Yeah, yes.
Okay. It's not a common exam question, but we can learn something from it. So let me confirm that this is 5 power Lg2, 2 power Lg3, 5 power Lg9, and 2 power Lg6. All these are power lah, or index, correct? It's not times lah. Let me just confirm that. Abigail, are you there? Can you hear me? Abigail, are you there? Can you hear me? Abigail, can you hear me? Abigail, can you hear me? How come you cannot hear me though? What's going on? Wait. How come I cannot hear you? What am I talking about? How come I cannot? Could you speak again? Okay. If you're speaking, Abigail, your mic is not registering at all. Your mic doesn't have the signal on one. If you are speaking, your mic is not capturing what you're saying. Right. Next week, I think we're going to use my device. All right. Now, I cannot hear it at all. I only have 3 minutes, so I'll try my best to explain to you, but you cannot talk to me as in your mic is not working. Tell me if it is okay. If that is okay, please type something. Okay, thank you. Notice this, and then also notice that. In a world of logarithm, base the same matters a lot. Currently, this is more like an in this world. I mean, power, 5 power, 5. I know the power is logarithm, but this is also in this. No surprises, please. Mentally, logarithm and in this basically coexist. Notice that it is in this, and notice the fact that the base is not the same. Too bad, low. Base 5, base 10, base 2, base 10. So a bit sad, but do not fail to notice that some of the base of the indices are the same. Base 5, base 2. In the world of indices, the same base, we can do a lot. So I'm going to focus on that first. Focus on the fact that this will become 5 Lg2 plus Lg9. And then this will become 2 Lg3 plus Lg6. Okay or not okay, you tell me? I am applying in this right now. All my in this knowledge. Good. Now, apply one of the law here. Tell me, you should be familiar with the law enough to recognize a opportunity here. Come on. Which law will make your life seemingly easier here? Logarithm law, I mean, not in this law. If you see it, write down. You cannot say anything to me. Quickly. We're running out of time. If you don't see it, say, I don't see it, like quickly also. Come on, base change, power in out, or no name law. You, you gotta learn how to see it, Abigail. Okay, I'm a bit surprised of that. Look, the no name law. No name law. Requirement base the same. Nothing in the middle, and this is a plus. No name law. I already tell you, you better see it. Do you see it? Okay, then apply it here, please, quickly. Don't waste time. Feel free to look at the previous Jamboard, but please apply that law. The law that reduces many logarithm into one. Okay, sure thing. Sure. 2 times 9 is something. Sure thing. All right. Put it back to the original. So this becomes what? Okay, nice. The other guy also. Do you see the opportunity for the other guy? I'm trying to see the opportunity. Okay. Respond to the training. Do you see an opportunity? Okay, good. Very good. Okay. Right. And then equals to quickly. All right. Right. Okay. Now, I'm not sure whether we stop, but we're at least at a simpler situation. I'm going to put it side by side right now. Currently, our situation means this and that. Our situation means we have 5 LG18 times 2 LG18. This is clear or not? Clear first or not? Not clear, please say. Now, I'm using my English knowledge again because frankly speaking, there is nothing to do with the logarithm. The base is not the same. But this is both logarithm and indice. I told you they will intermix one freely. So according to my indice knowledge, hey, the power the same is also a big deal. It's also a big deal. People don't seem to be comfortable with this one. I'm going to say it immediately. This will immediately become 5 times 2, LG18. I don't consider this memorization usually. I consider this, hey, the power the same, I can do something. Initially, the base the same, I can do something. Now the power the same, I can do something. If you don't understand this, please say that. Good. If you understand, then please tell me what's 5 times 2? 10, and then power LG18. Go ahead. And then you see the final step. Do you see it? Come on. Come on. See the final step. Do you see it? What did you write? Sorry. Do you see it? If you see it, just do it. I mean, if you see it, just do it. Oh no, that's a no. Okay, I'm not very happy with your logarithm right now. If you don't see it, all I'm teaching you today is, do you see this benefit? Do you see that benefit? If you don't see the benefit in front of you, listen to your class more. I'll leave the final step to you. I expect next week you can do this. Now, having said that, this is the future, right? This is what the future holds. So if you cannot even see this final step, pay attention in class more. This is basics of logarithm. When we discuss the future thing, by right, it makes your class more understandable. That's true. Now, I expect you to be able to finish this next week. I also expect next week we devote more time to discussing the future, not just reacting to your homework. Okay? Believe it or not, that doesn't help you too much. Good job for today, and I will see you. Bye.